In this experiment, you will determine the percent copper in an unknown compound by first determining the absorbencies of 4 solutions containing accurately known quantities of copper. Then you will compare these to the absorbance of a solution containing a carefully measured amount of an unknown material. You will begin by using a 50 milliliter beaker to weigh out approximately 0.30 grams of pure copper metal. You will do this on the analytical balance and be sure to record every digit. In the hood, add approximately 5 milliliters of concentrated nitric acid. Make sure you are wearing gloves.
Place the beaker on a hot plate. The copper metal should dissolve, producing a brown, rich gas in an emerald green solution. When all the NO2 has been driven off, the solution in the beaker should be a sky blue color. Rinse the side of the beaker with deionized water to prevent any loss of copper. Transfer the copper solution into a 200 milliliter volumetric flask and make sure to rinse the edges of the beaker to prevent loss of copper once again. Fill the flask half full with deionized water and then add 15 milliliters of the concentrated NH3 solution. The solution should change to a dark blue color. Carefully dilute the solution to the mark using deionized water. Mix the solution by carefully inverting it 10 times. Then transfer the copper solution from the volumetric flask into the 200 milliliter beaker. Label that beaker's solution 1. Using a 50 milliliter pipette, transfer 100 milliliters of standard solution 1 back into the rinsed 200 milliliter volumetric flask. In the hood, add 5 milliliters of NH3 and dilute to the mark using deionized water. Once again, invert the solution and dump it into a new, clean 200 milliliter beaker. Rinse the volumetric flask and dispose of its contents, and then pipette 100 milliliters of standard solution 2 into a new volumetric flask. Once again, add 5 milliliters of NH3, dilute to the mark, and invert the solution. This will be standard solution 3. Prepare standard solution number 4 in the same fashion. You should now have 4 standard solutions, each prepared from the preceding solution. Now you will prepare your unknown. Weigh out 0.30 grams on an analytical balance. Make sure to record all digits and which unknown you have. Dissolve this in approximately 25 milliliters of deionized water in a small beaker and quantitatively transfer the solution to the rinsed 200 milliliter volumetric flask. Add 50 milliliters of water, 15 milliliters of NH3, and dilute to the mark. Once again, invert 10 times. This is your unknown solution. Instructions will be provided on how to use the spectrometer. Turn knob B to the desired wavelength, which is approximately 600. Next, you will calibrate it. Turn knob A to 0 on the %T scale. Next, you will prepare a blank solution. Fill the cuvette half full with deionized water and place into the spectrometer, aligning the white line with that on the spectrometer. Fill the cuvette halfway with solution 1 and then place it in the spectrometer. Record the absorbance for each solution. Before you prepare the next solution in the cuvette, use the fill-dump-fill method to clean the cuvette. All copper-containing solutions should be disposed of in the indicated copper waste container. Do not pour them down the drain.